Hello everyone, my name is Josiah Livens. I am making a video for 10 common programming errors in Java. This is not necessarily tied to Java. You can be programming this in C++ or C# or PHP and you will still run into these errors most of the time. They might look a little bit different, but the underlying reasons why they occur will probably remain the same. I will be using Eclipse and Neon for doing the demonstrations, so if you haven't already got that, that's going to be what I'm using. So I would recommend that you have that open so you can work along with me. So the first common programming error is cannot resolve symbol. Most of the time this happens because either the symbol is out of scope, they're trying to use a variable that doesn't exist, or they didn't name it properly, they didn't declare it. The example that I have here is, for example, if you have a variable called cache, ask yourself, what data type is it? Like, do you know, like, does the cache variable hold a string, an int, or a double, or a short, or a long? This is in reality a trick question. You can't possibly know what it is. You don't know whether it can only hold whole numbers, or whether it can hold large decimals, or small whole numbers, or maybe it's a string. Who knows? But you can't know that, and neither can the compiler. So we should have this, and what we want to do is do public static void main. We do string, and that's going to be an array, and then args, which stands for arguments. So we have this, and what we're going to be doing is cannot resolve symbol error. Normally how a cannot resolve symbol error occurs is when we have something such as int x equals 9, for example, and then we try to have x equal itself plus, let's say, y. So we get an error here. So it's saying that it cannot be resolved. This will say cannot be resolved to an error variable, but it might also say cannot be resolved to a type, or it might just say cannot be resolved to a symbol. It depends on what IDE, what compiler you're using, but almost always when it says cannot be resolved, it's saying it has no idea what the heck this is. So we'll go and run this, try to run it. So we'll go and we'll say always save them. Now, I always recommend, I'm doing this for demonstration purposes. However, never do this. This is a very probably dumb thing to do because you'll go and get used to this and then you'll get even worse errors. Always resolve them inside the editor when you can. So it's saying unresolved, cannot be resolved to a variable, or it might say it cannot be resolved to a type, but basically it's saying it doesn't know what this symbol means. We can also have something such as, let's use the example here. We'll go and do stem.out.print line and we'll do cache as the example I had before. So, like we had before, and like the question that I asked, is cache, what does cache represent? Does it represent money, or does it represent some kind of string? We don't know. Now, let's say that we have like cache equals 654. Now, while that does narrow down generally what we think it's going to be, we don't know whether it's an int, we don't know whether it's going to be a short or a long, because we haven't defined its data type. And because of that, it can't resolve the symbol. So we want to go and define, yes, it's going to be an int. Another example that a lot of students run into is when they declare something such as, when a programmer has something such as maybe nickname, and then we try to set nickname. Now notice the error that it's giving. It's saying it cannot be resolved to a variable, but we have it here. So what's the issue? Well, the issue is that we added an uppercase letter to this. And that makes this variable and this variable completely different. So what we need to do is get rid of the n, and they'll be the same. Same as spelling. If we do that, it cannot resolve the symbol because they're both exactly the same. Many new programmers and many experienced programmers will run into this issue quite a bit, especially when the names get long or complicated or possibly poorly spelled. So most of the time, this is usually what happens when a cannot be resolved error occurs. This can also happen when we're also trying to do something with scanner. Notice that it's saying something pretty similar, however, it's saying it cannot be resolved to a type. So basically it's saying it cannot be resolved to whatever type it's supposed to be. Now, what do you think is wrong? Well, we did not import scanner. So right now it has no idea what scanner is supposed to be. It doesn't know whether it's supposed to blow up the computer or read names or do a dance, who knows. So we need to go and define that scanner. We're going to be using one in Java, in util. We're going to use that scanner. That's what we'll have there. So most of the time this is what happens. Usually either the programmer didn't import it properly, didn't declare it, or screwed up the name, maybe by capitalizing something, or by adding an extra letter and spelling it wrong. Our next error is a pretty simple one. It is simply missing the semicolon at the end of a statement. This mostly happens when students or novice programmers or even experienced programmers get a tad lazy and do not compile after writing lots of code. Most of the time this can be fixed very, very quickly since the compiler should highlight lines that have the missing semicolons. However, if you don't compile very often, you'll get a large number of mistakes. The semicolon expected error is probably one of the most common errors that any programmer will run into. There are some languages that don't have semicolons, but most of the very powerful ones and most used ones require a semicolon. Usually what happens is we'll have something such as an x equals 9. And you'll notice that it's going to be saying something to the effect of that there's a missing semicolon. You'll notice that Eclipse is giving a far better, more concise error message than just semicolon expected. However, if we do something such as, you'll notice that we'll get a semicolon expected. Now, this is due to using colons instead of a semicolon. Now, there are other issues such as saying that a period was expected. Usually this is probably due to it trying to figure out what exactly you're trying to do. Now, if we go and fix the semicolon issue in the for loop, you'll see that none of those errors show up. Most of the time, this is the error that many new programmers make. Usually it's their for loops, or it's their statements, or it can be due to bad formatting, such as, this is a good example of sloppy programming. I definitely would not recommend doing it this way, and this is a good example of why it is important to make sure that everything is spaced properly, everything is tabbed properly. Many novice programmers severely underestimate how important it is to make sure that the formatting is correct, because they will run into errors if it's not properly formatted. So you'll notice here, it's quite obvious that we need to add a semicolon here since this is a statement. The illegal start of expression error usually occurs when either some logical operators are incorrectly inputted or some parentheses are messed up. An illegal start of expression error usually occurs with how the tokens are placed inside of expressions, especially inside of if statements or while loops or possibly for loops. Now you'll notice that Eclipse actually gives a more detailed error to me. So I can more easily go and fix this. It's saying for me to merge these. But you'll run into errors such as trying to do something such as this. And of course it's saying to delete this token. And tokens are just these logical operators. This can also happen when you're trying to use other methods. Now, many students, when they go up into working with methods, normally due to bad formatting, they will usually forget an ending brace here. This is usually also an example of an illegal start of expression, because it will be assuming that this is supposed to be some kind of expression inside of this, and it generally screws up the entire thing. So always make sure that you have your braces correct and you have your parentheses correct, or else you might do something like this. You will have a strange parenthesis problem. You need to make sure that they're all closed. Now, an identifier expected error usually occurs when a student or a programmer tries to use a field that has not been declared with a data type. So here is an example of a field being declared. Notice that we are getting some kind of strange error. Now it is giving this error because it is thinking that I am going and trying to make a method, which I am not. So what we need to do is add a data type here. But just for kicks, we'll go and try to assign a value to that field. And notice that we're getting some kind of bizarre resolved variable, and it is not finding this one. And this is due to us trying to add a value, but we don't know whether this is a string or an int or a short or a long. Who knows? So we're going to say that this is an int. And all of this magically goes away. And here's a good side note. It is giving me this error because I am trying to reference this variable inside of a static method. You just need to go and put static at the start of this, and that will fix your issue. Hopefully I will have some kind of video covering static, since it is usually a very confusing subject for new programmers. So we have already covered a little bit of this subject. However, it is still very, very important, and it is usually a very simple error that can be avoided by good formatting. Now, usually the parentheses or brace expected error occurs from bad formatting. For example, now you will notice that this is incredibly hard to read. And you'll notice down here, you'll be getting some kind of strange syntax error, saying insert a closing bracket to complete the class body. So we can go and edit that there, but of course we're still a little bit more confused now. Where does this one go? To here. Now the IDE does have some nice referencing, it'll see it there, but if you go and show this code to any other programmer or anyone who's supposed to go and read this, they will get very, very angry. Because if you look here, you'll see that this if statement is going there, but then you thought that it was supposed to go here. So the proper way is you need to go and fix a lot of this formatting. So I will go and fix this. Notice how much easier it is to read this now, because we have this, see that, see that, see that, and we'll know that there is something missing here, because it's pretty easy to see that this goes here, and this one goes here. So we'll go and add that in there, and all of the errors go away. And the same goes for a Boolean. If you're having something such as, you'll notice that there are a lot of parentheses, and there are some expressions that might be even more complicated. Now, this can be broken up using Booleans, which I will cover a little bit later in this video. However, it is simply important to know that every parentheses needs a closing one, and always be careful when you're adding these. Incompatible types is an error that usually occurs when a programmer is trying to assign one variable to another, and they seem to have similar types of values, when actually they have very different types of values. This can happen either from incorrect assignments, not working properly with Booleans and other variables, or simply assigning some kind of variable to another similar looking type of variable. Now, incompatible types usually occur when a programmer is trying to assign perhaps a long to an int, or something such as assigning a char variable to a string. For example, you will notice that we are getting an error saying that it cannot convert from a long to an int. And this is due to the loss of information. Since an int is a smaller container, if you think of it as a smaller container, and y is a larger container, then you will be losing some information. So if you have something, for example, much longer, such as that, then you will most likely lose some of the information that you're trying to add into the int. This is usually resolved by casting it as an int. And basically what happens is you're calling some kind of function that goes and edits this number to fit nicely into the int variable. This is the same with a string and char. You will notice that there is an error that occurs when you try converting from a char to a string. Basically this is resolved by calling a method from the string class. And basically what this does is it finds a value of the char variable and puts it into be done by simply having a blank string and adding the char variable to it. This can also happen if you're making some kind of if statement and you make the mistake of trying to set x to equal true, which x is 9, so you can't really tell whether it's going to be true or false. Now, Java is a case-sensitive language, which means that if you do not have a variable that is exactly the same name as whatever you declared it as, it will count it as, it will not be able to resolve it as a symbol. So for example, and many beginner programmers, many students that I've seen will make this mistake. An example being that you have a string, they might have given it some kind of name and then they give it a bigger case name, and then they try to call this, which these two are completely different. So naming and capitalization is very important. If I make some kind of integer, or we'll go and make this a string, name, and we'll set that equal to Josiah. Now, if we want to system out this, you'll notice that works. However, if we change this, you'll get a cannot resolve variable name. Or if you make it lowercase and you make it plural, you'll still get cannot resolve variable. So it is very important that you always check that when you name something like this, that it makes sense to you, and then that you name it this way. Another common issue that actually occurs is when students mess up naming something else. For example, the class name here must be the same as whatever Java class that you currently have. If you change this, if we remove this, you will get an error, and it's offering to rename the class file so it makes sense. Of course, we want to keep it like that. And right now, we're able to run it, and we get Josiah. However, we would go and make main capital and try running it. It cannot find it, because this is a completely different method from whatever this is. This is the same for string. Of course, it has no idea what this is. And, especially, above all, is the system out print line. Many students and beginner programmers will make this common mistake. It is obviously a very simple mistake and can be fixed very quickly. The not a statement error occurs usually when the programmer is attempting to not perform any assignments or actually not create an actual statement, such as var plus is cool. This will not do anything. Nothing is done after it. And even if it has a semicolon, there's no assignment and there's no real operator going on. Here is a practical example of what not a statement probably looks like. Instead of doing an assignment, we might have something such as a plus. Now, of course, Eclipse is smart enough to know that a plus is not an assignment operator. Now ask yourself, what is an assignment operator? Well, this is an assignment operator. You're assigning value this to a string called var. This is not assigning. This is trying to add this to this, but nothing is ever actually being assigned or changed. Also, if you remove the semicolon, you will have something that is also not a statement. Since there's no semicolon, the statement doesn't end and it'll go all the way down the lines, and it generally makes an entire mess. And we can even add the assignment operator, and it still will not fix this. And it's saying that you need the semicolon to complete the statement. Now, Boolean logic errors are probably one of the more difficult issues that students and new programmers are probably going to run into. The main reason being that the concept of a Boolean variable is pretty abstract. It's hard to understand how you can have a variable that is of only two values. Unfortunately, also, usually beginner programmers and beginner students might not know how to test their Boolean logic to see whether it is giving the expected result. For example, the example I have here is having a Boolean example 1 equal to true, and having Boolean example 2 equal to false. Now, if we have a while loop and have example 1 or example 2, will this loop? So basically, for example here, since one of these is true, and basically what we're saying is, while this entire expression is true, keep looping. Since one of them is true, then it's basically saying, if either this or this is true, keep looping. Now, we'll go and test this Boolean logic using a while loop, and we'll just have it system out print hi. You'll notice that there is an error right now because it is expecting some kind of expression after this parentheses. We don't have an expression in here. And remember that an expression is essentially a statement that doesn't require a semicolon, usually. So we'll have two int variables. We'll just deal with those two for now. So we'll go and have it loop, so while x is less than y. So ask yourself, what is the value of x? What is the value of y? X is 0, y is 9, and this symbol means it's less than. We could also have this, so while x is more than, while it's less than or equal to, while it's more than or equal to, and while it's equal to y, or not equal to y. For kicks and giggles, we'll just do this. Usually a lot of students make this mistake. The greater than symbol or less than symbol always needs to be on the left side, then you'll have the comparison equal on this side. And always remember that it's double equals, not single equals. Because notice up here, we're not saying is y equal to 9, we're saying that y is equal to 9. So the double operator is asking, is x equal to y? Now, if we run it, you'll notice that it doesn't loop at all. Why do you think this is? Well, we're saying, okay, so we want you to loop while x is equal to y. Is 9 equal to 0? No, it's not. So it didn't even loop once, and we want it to at least loop once. So we'll fix this. So x is currently less than y, so we'll just have it loop while x is less than or equal to y. And so it's outputting. However, it's not stopping. And the problem is that x is 0, y is 9. And when is 0 ever going to be equal to 9? It's never going to be equal to that. We need to go and change x so that it starts increasing. So we'll do something such as x equal to 9. Notice that it is still looping forever because it's equal to 9. So is 9 equal to 9? It's true. So it'll keep looping. So we're going to go fix this. We're going to make this 10. And it only does it once because it goes here. Is x less than or equal to y? Yes, x is 0. It's less than 9. So we'll go in here, say hi, x equals 10. Is 10 less than or equal to 9? It is not less than or equal to 9, so the while loop ends. Now we'll get a little bit more complex. So we'll do x equals x plus 1. We'll run it, and it doesn't do any infinite loops. It just outputs a few times. This is because x is 0, print it out, 0 equals 0 plus 1, or x is equal to 0 plus 1, so x is now 1. And then we keep going and doing this loop all the way until x is greater than y, which is 10. Now, we might want to do something more complicated, such as or y is equal to x. We'll go and change this, so it's just less than. Run it, and it doesn't loop infinitely either. Then, a good set of advice that I can give you. Hopefully I will do a more in-depth video, since there are 10 errors that we're covering. I'm not going to devote a whole lot of time, but if you want to know whether an expression is registering true or false, which the while loop will only loop when whatever's in here finalizes to true, you want to do system out, and you just need to go and copy whatever you have in here and here, and then you can go and do this. And notice that it outputs true. These output true. We'll put an exclamation point. Still true. Well, x is more than y. Still true. And notice that x is not more than y though. So why is this? Well, is x more than y? False. Or is y not equal to x? That is true. Since we have an or symbol, this is going to be true, since this is true. Now if we make this an and, which basically means both this and this have to be true for this entire statement to be true, we run this, it will be false. Notice that's false. So since this is false, this is true, but we have an and, this will all register false. And this is probably one of the better ways. You can also go into debugging, which I'm not going to go into right now, but you can break it down even further by checking whether x is less than or equal to y. We can check that, and we can check this. And notice that this one is false, this one true, but this overall statement is false. And I usually use this strategy quite a lot, and it's very, very useful, especially when you have larger expressions that are increasingly complicated. Now, a null pointer exception is probably one of the harder errors or exceptions to wrap your head around. Many students will run into this, usually because they fail to understand the difference between declaring and initializing and then trying to use something. A great example is having an integer x and then system out print whatever x is. Now, ask yourself, what value is x? You won't be able to tell me, and the compiler will have no idea what value x is supposed to be. Is it 9? Is it 10? We don't know, but you're somehow trying to display it, which will throw a compiler error. Here is the error in action. Now notice that it is already throwing an error saying that the variable x might not have been initialized. Now this is very nice because some other IDEs will not tell you this. They'll usually just say that there is a null pointer. And if we try running this and we try to force it, it'll once again point out that it has not been initialized. It has no idea what value this is supposed to be. So if we have something such as that, try running it, then it works fine. Now, here is a larger example, and probably a much more confusing example. Now, notice that there is an error here. If we try running this, we'll get cannot be resolved to a variable. But you might be wondering, well, we have it declared, we have it initialized, why is this a problem? And since if we have x equals 10, does 10 equals 10? True. We have int y equals 8. This should be just fine. This should be declaring 8. Well, this will not work the way that you probably hoped. Because if x equals 5, what value is going to be y? Well, it's not going to be either of these. So you're trying to system out print something that doesn't exist. Also, this is in a different scope. We would need to declare y outside of the if statement. Essentially, a scope is when you try declaring a variable inside of brackets. And these go and change the scope. Now, if we go and move int y, we go and put it here, and then we just remove these ints, you'll notice that we still have an error, but it's a different one. It's saying that it has not been initialized. So it's seeing this, but saying it's not initialized. Now, what if we go and change this to 10? So we'll not fix the issue, because it does not like the fact that we don't have anything where if x is any number, it still does not like this. So it does not like the fact that if x does not equal this, or it does not equal this, it's still going to be outputting some kind of null pointer. And what we usually need to do is we can use an else statement and then set y equal to some number, such as 0. Now notice that the error has gone away. So if x equals 3, then will this execute? No, 3 is not equal to 10, so y will not be set to 8. Y is still null. Then, if we go to this if statement, is 3 equal to 12? No, so y will not be equal to 17. But we have an else statement. So if 3 is not equal to 12, we'll just do this, and we'll set y equal to 0. This can also be fixed. Notice that the error is back by setting y to equal to 0 at the start, and then we don't need to deal with any of that down the road. Usually I end up trying to initialize my variables as soon as I possibly can. Usually I put them at the start. And just to clarify that this is declaring, and then this is initializing. And if it is inside an inner bracket, then it is at a different scope. So I just wanted to go and take some time to explain how scopes work, because you need to go and understand these in order to understand null pointers. Most of the time, null pointers are the cause of misunderstanding scopes. So I think that this is very important. So you'll notice that this is the code from the program that I showed you a few moments ago. You'll see that you have the if statement, and inside the if statement you have the y. And notice that these y variables are a different scope from what is beneath it. All of these code, the print stands for system print out print, is one scope, while the main method is a larger scope, and the class error tester is probably the largest scope. So if you think of this as a pyramid or something like that, you'll know that the class error tester has some brackets, and then the main method is inside those brackets, and then the code for the main method is inside those brackets. And then you'll see that the y is inside the brackets of the if statement. So right now we already have y established. And so when you go and call this, it's going in either looking at its current scope or a lower scope. So if you have this if statement, y equals 8, okay, which y are we talking about? Well, let's go down one scope, and we'll see that we have a y here. And we'll go and print that out. So we change this and change it in here. And if we instead initialize y in here, you'll go and see that you'll get a null pointer. So this is code that will result in a null pointer. We have x, initialize it to 3. However, we declare y up here. So this is in a different scope. Now, you're assigning it here, and it's already been changed. But when we get here, we have print y. Well, which y are we talking about? Well, it's going to be either looking at its current scope or lower down. And if you want to go and reference the code that I made a few moments ago, this might make a little bit more sense, but I feel that this can clarify some things. So since it is in here, and since you've declared it in here, then you will get a null pointer because it doesn't know what y it is. The compiler is looking here, and then it's going down the scopes. Now, if we look back here, we've already declared y here. So we can go and change it. It'll go and say, oh, what y are we talking about? It'll look down and see that there's one here, and it'll change that one. Hopefully that this makes it a little bit clearer that when you try to use y, it has to be declared in that current scope or something below it. This one is not declared in the current scope or below it. It is declared up here. So this, we'll go looking for it. It's looking, doesn't see any declared y, so we'll throw a null pointer exception. And that is the video. Hopefully it helped. Give me some feedback. Feel free to subscribe. Give me some feedback, especially on the editing, stuff like that.